Hello guys, welcome to Kerala Neet Academy. This is IST and today we'll be discussing a very important topic, VSEPR theory from the chapter Chemical Bonding and Molecular Structure. So are you ready? Now we'll start. So as you know, VSEPR theory, one of the most important theory to predict the geometry, the shape of molecules. So after completing this theory, this class, you'll be able to predict the shape of most of the molecules. Okay, now we start. So valence shell electron pair repulsion theory. So in every molecule, we'll be having two types of electron pairs. You know that they are called bond pair of electrons and lone pair of electrons. Those electrons which participate in bond formation, they are called bond pair of electrons. And those valence electrons which does not participate in bond formation, they are called lone pair of electrons. So the only thing is that you should know the number of these pairs of electrons. If you know the numbers of these pairs of electrons, then you'll be able to predict the shape of the molecule. Now we can classify the molecule into two types. The first case will be the molecule without lone pair and the molecule which is carrying one or more lone pair around the central atom. And before just going for that concept, let's see the number of valence electron that will be present in different atoms. Now, if you take an atom from group 13, 14, 15, 16, 17, and 18. So if the central atom, if they comes from group 13, then you'll be having three valence electrons. Okay, you'll be having three valence electrons. That means boron, aluminum, gallium, indium. All these category elements will be having three valence electron. Then from carbon family, 4, nitrogen family, 5 valence electron, oxygen family, 6 valence electron, halogens will be carrying 7 valence electron, and group 18, they'll be having 8 valence electron except helium. Okay, now these valence electrons will be participating in bond formation. And now the atom to which the bond is formed, that depends now whether it is a single bond, double bond, triple bond, etc. Now, if you take the case of oxygen atom, if the oxygen atom is not the central atom, that means if it makes bond with a central atom, means oxygen will always make a double bond with the central metal atom. You consider a molecule like carbon dioxide, so that carbon and oxygen that will be making a double bond. If you take the case of hydrogen atom, hydrogen atom will be making a single bond with the central metal atom, and halogen atom will always make a single bond. So halogen means fluorine, chlorine, bromine, iodine. Okay, we'll take all these halogens. So by knowing the type of bond that is created by a particular atom, we will be able to calculate how many bond pairs and how many lone pair of electrons are present in a particular molecule. Now here, according to VSEPR theory, you can see the postulate. The shape of a molecule depends upon the number of valence shell electron pair around the central atom. For example, if you take the case of H2O molecule, you can see that oxygen bonded with the two hydrogen atoms, and they will be carrying two lone pair of electrons. In H2O, so that you'll be having two bond pairs. Okay, now this is the first bond pair and this is the second bond pair. So you're having two bond pairs, and see, this is one lone pair and this is your second lone pair, and it will be carrying two lone pairs. This is enough. If you know the number of bond pairs and lone pairs, then you'll be able to decide the shape. So a molecule which carries two bond pair and two lone pair will be having a bend shape. But before that, we should see how to identify the number of bond pairs and lone pairs. According to VSEPR theory, the multiple bonds, see if it is C single bond C, or I can say X single bond X, that will be treated as a single bond pair. And now if it is X double bond X means that is treated as one double bond pair. That means you have to count it as a single bond pair. That means even if it is a double bond, that will be treated as a one bond pair. Okay. And if it is triple bond X, that also will be treated as one bond pair. That means a multiple bond is treated as if it is a single electron pair. For example, if I take C double bond O double bond O. So you should not count it as 4 bond pair. It should be treated as 1 bond pair. That means a double bond pair. Now you are having 1 double bond pair and 1 more double bond pair. So total bond pair will be taken as 2. So by knowing the number of valence shell electron pairs, now you will see how to predict the shape of the molecule. Okay, now listen. First we'll take the molecule in central atom without any lone pair. So without any lone pair means we can classify them into 5 types, like AB2 type, AB3, AB4, AB5 and AB6, where A is the central atom and B will be the atoms which makes bond with the central atom. So AB2 type molecule, if it comes from AB2, then the shape of the molecule will be linear shape. If it is AB3, if you are having 3 bond pairs without lone pair, then it will be trigonal planar. 4 bond pairs means tetrahedral. 5 bond pairs, trigonal bipyramidal, and 6 bond pairs, if it carries, then it will be having an octahedral shape. And now, the second type, now you will see the different shapes. See, now this is called the linear shape. Okay, now AB2, now this is called the linear shape of the molecule. This is called the trigonal planar. This will be the tetrahedral shape, then trigonal bipyramidal, and the last one which is called the octahedral. Now we'll move on to the next types. First we'll get familiarized with the types and after that we'll go for the examples. Okay. Now the second type which is called molecule carrying 1 or more lone pairs. Now when the central atom has 1 or more lone pair along with bond pair, we can classify them as AB2E, where E represents the number of lone pair and B will be representing the number of bond pair. So AB2E type means you are having 2 bond pair and 2 bond pair and 1 lone pair. And AB3E, in AB3E type, you are having 3 bond pairs and 1 lone pair. AB2E2, 2. AB4E will be having 4 bond pair and 1 lone pair. AB3E2 will be having 3 bond pair and 2 lone pair, and so on. So if a molecule belongs to AB2E type, then it will be having a bend shape. AB3E means it will be having a trigonal pyramidal shape. AB2E2, again, it will be having a bend shape. AB4E, seesaw. AB3E2, T-shape. AB5E, square pyramid. And AB4E2 will be square planar. And now, see, these are the different geometries of AB2E, AB3E2, etc. So here, now we'll see how to recognize the shape of a molecule. Now, before that, always, once again, I'm telling, listen here. Now, like the central metal atom, hydrogen will make single bond, then halogen will make single bond, and oxygen will be making double bond. And see, in case of the valence electron, group 13 member, if the central atom, if they comes from group 13, then it will be carrying 3, 14 to 4, 5, 6, 7, and 8. Now we'll take an example. Now we need to know what will be the shape of sulfur dioxide. Okay, now let me take the shape of SO2. In case of SO2, the central atom is sulfur. The central atom will be sulfur, and sulfur comes from group 16. Okay, sulfur comes from group 16. Group 16 means sulfur atom will be having 6 valence electron. Okay, 1, 2, 3, 4, 5, 6. So sulfur atom comes with 6 valence electrons, and now oxygen atom has to make bond with this sulfur. And you know that oxygen atom will always make double bond. Oxygen atom will always make double bond with central atom. So here, if oxygen atom, it takes 2 electrons from sulfur. Next oxygen atom, that also will take 2 electrons from sulfur. The remaining, you'll be having 1 lone pair. That means 2 non-bonded electrons will be treated as 1 bond pair. So it is of the type, now I can say there are 2 bond pairs. There are 2 bond pairs and 1 lone pair. So it is, only 1 lone pair. So it will be of the type, AB2E type. AB2E type. And if a molecule come with AB2E, then we can predict the shape of the molecule. AB2E means that will be having a bend shape. That means sulfur dioxide molecule, SO2 molecule, will be having a bend shape because it is of AB2E type. So whenever we are getting a molecule, we need to identify the number of bond pairs and number of lone pairs. Remember, a double bond will be treated as a single bond pair. Okay, so This double bond will be one bond pair, and this is your second bond pair. Don't take 4 bond pairs. It will be double bond. You have to treat it as a single electron pair. Okay. So we'll go with more examples. Now listen. Let me take the case of carbon dioxide. We'll take the case of CO2. Now, which is the central atom in CO2? The central atom in CO2 is carbon. And carbon comes from group 14, which means carbon atom will be having 4 valence electron. 1, 2, 3, 4. And now this oxygen atom, the oxygen atom has to make bond with the carbon. You know that 2 electron will be taken by one oxygen, and the remaining 2 electron will be taken by another oxygen. So this belongs to which type? This is AB2 type. This is AB2 type. And does it carry any lone pair? No. So here CO2 will be AB2 type. So in AB2 type without lone pair, AB2 type without lone pair means they will be having a linear shape. So AB2 type. So before going for this one, you have to by heart the structures AB2, AB3, etc. Okay. Now if you take another example, now let us go for NH3 molecule, ammonia, NH3 molecule. In case of NH3 molecule, the central atom is nitrogen. You know the central atom is nitrogen, and it comes from group 15. So group 15, the nitrogen atom will be carrying 1, 2, 3, 4, and 5 valence electrons. So 5 valence electrons. So now the hydrogen atom has to make bond with the nitrogen. Central atom nitrogen. So hydrogen atom will make bond with the central nitrogen. And you know that hydrogen atom will always make single bond. So 1 electron bonded with 1 hydrogen, second electron bonded with second hydrogen, and third electron bonded with the third hydrogen. As a result, it develops 3 bond pairs. 3 bond pairs are developed. So if A is nitrogen and B will be hydrogen, so it will be AB3. And remaining, it carries one lone pair. So AB3E type. AB3E type means the shape will be trigonal pyramidal. Okay, so ammonia molecule will be having a trigonal pyramidal shape. Now again, we will take another example. We'll take the example of like H2O molecule. Okay, H2O molecule, water molecule. Now we'll take the case of ClF3. Okay, we'll take the case of ClF3. ClF3 is the central atom. The central atom is chlorine, and that comes from group 17. So you know that chlorine atom will be carrying 1, 2, 3, 4, 5, 6, and 7 valence electron. And now we'll see fluorine. It's a halogen, and fluorine will always make single bond. So fluorine will be bonded with the chlorine. Now 1, 2, and 3. So it will be like AB3 type. Okay, AB3 type. And remaining how many lone pairs? See, you are having total of 4 non-bonded electrons. So 4 non-bonded electron means that will be making 2 lone pairs. So AB3E2. And what will be the shape of AB3E2? So AB3E2 molecule. Okay, AB3E2 molecule will be having a T shape. So the shape of this particular ClF3, that molecule will be having a T shape. Okay, T shape. So here with the presence of that lone pair, the molecule will be having, so it will be having this, like if you go in detail, that will be having a slightly bent T shape. But anyhow, we'll go with the T shape itself. Okay. Now, I'll give you some example. Now, if you take the case of CH4, okay, CH4. Now, if you take the case of BeCl2, then PCl5, SF6, okay, all these are different molecules. Now, we'll take the case of CH4, methane. Methane, central atom is carbon. Okay, so I'll underline the central atoms. Okay, these are called central atom. And carbon, that comes with the 4 valence electron. And each hydrogen atom will be bonded with each electron because hydrogen will make single bond. So carbon, you are having carbon, it carries 4 valence electron. And each valence electron, because hydrogen will be making single bond. So 1, 2, 3, and 4. So 4 single bonds. So after making bond with the carbon atom, there is no valence electron. All the electrons are now utilized. So it is AB4 type. Yeah, AB4 type. So AB4 type means the shape will be tetrahedral. The shape will be tetrahedral. Now BeCl2, if you take the case of beryllium chloride, beryllium that belongs to group 2. Say group 2 will be having 2 valence electron. So beryllium, Be, beryllium with 2 valence electron, and chlorine will make single bond because chlorine was the halogen that will be making single bond. So it will be like AB2 type without lone pair. AB2 type without lone pair means the shape will be linear shape, linear. PCl5. In case of PCl5, phosphorus comes from group 15. Phosphorus group 15 member. Group 15 member how they will be having 5 valence electrons. Okay, 5 valence electron will be there. So phosphorus 1, 2, 3, 4, and 5. And you know the chlorine atom we have to make single bond. So each chlorine atom will make one bond. So one chlorine, second, third, fourth, and fifth. So 5 chlorine atom, after making bond, it will be like AB5 without lone pair. Because all the valence electrons are now participated in bond formation. As a result, the molecule will be having trigonal bipyramidal geometry. Okay, bipyramidal geometry. Then if you take the case of SF6, okay. Now in case of sulfur hexafluoride, sulfur group 16, group 16. Group 16 means 6 valence electron. So sulfur will be carrying 1, 2, 3, 4, 5, and 6 valence electron. And to that sulfur atom, fluorine has to make bond. Now tell me how many bonds will be created by one fluorine atom. Fluorine will always make single bond. If oxygen atom is depending only on one atom, then oxygen will be making 2 bonds. If hydrogen atom will always make single bond. And remember, oxygen will make double bond, or it can have 2 single bonds. Okay, now in this case, the only condition is that oxygen requires 2 bonds. So in our case, oxygen will be making a double bond with the central atom. Now for this fluorine, now first fluorine, second fluorine, third one, then you have the fourth, fifth, and sixth. Now all the fluorine atoms are bonded. When all the fluorine atoms are bonded, now listen, this particular geometry, this is called AB6 type without lone pair. AB6 type without lone pair, so this particular shape is called octahedral. We call it as octahedral geometry. Now we'll go for more examples. Okay, now listen here. We take XCO3. Okay, XCO3. Now XCO3, now you know that xenon is a group 18 member. Group 18 member means it will be carrying 8 valence electron. 1, 2, 3, 4, 5, 6, 7, 8. And now 3 oxygen atom has to be bonded with this central xenon. And you know, so like that means oxygen will always make double bond with the central atom. So here the first oxygen atom will take 2 electrons. Second oxygen atom, again that will take 2 electrons. Third oxygen atom, that also will be taking the remaining, that means the 5th and 6th electron. Now after bond formation, you are having a lone pair of electron left without bonding. So which category this will be belonging to? See, one bond pair, second bond pair, and the third bond pair. So XCO3 will be of the type AB3E. Okay, XCO3, this X, A represents xenon, B will be representing oxygen, and E will be representing the lone pair. So it is like AB3E type. AB3E type molecule will be having a trigonal pyramidal geometry. Okay, so XCO3 that will be learning in P block element, and that molecule is having a trigonal pyramidal geometry. Now if you take another example, now we'll take the example of SF4. In case of SF4, now listen, sulfur with 6 valence electron, and fluorine, you know that fluorine, what type of bond? It will always make single bond. So first fluorine, second fluorine, third, and fourth. So it will be, so which category it belongs to? It belongs to AB4E category. AB4E. And what will be the shape of AB4E? AB4E molecule will be having a seesaw shape. They'll be having a seesaw shape. That means SF4 will be having a seesaw geometry. So any molecule if you get, we can predict the geometry. Now if you take the case of BCl3, now let's take the case of BCl3. In case of BCl3, boron will be having 3 valence electron. Each chlorine atom will make single bond. So it will be like AB3. Okay. So AB3 type without lone pair. Will be having a trigonal planar geometry. So this is how we are predicting. The shape of different molecules. So once again, now we can classify molecules into AB2, AB3, AB4, AB5, and AB6. And next classification based on lone pair. These are the different classifications. And just by heart these values. And then should know the number of bond pairs and lone pairs. So this will be the type of bond that will be created, which means I told you like oxygen will be like making double bond with central atom, halogens will be making single bond, and hydrogen that also will be making single bond. Okay, so here one oxygen atom will consume 2 electrons. Clear? One oxygen atom will consume 2 valence electron of the central atom. Halogen will consume 1 electron, and hydrogen also will take 1 electron. So if there are any electrons are there left without participating in the bond formation, such electrons are called lone pair. So by knowing the number of lone pairs and bond pairs, now you are ready to identify the shape of a molecule. Hope this session is clear. Thank you.